Hi, my name is Nicole Herskowitz, and today we're going to walk you through the Azure Application Platform. We're going to spend some time talking about the overall platform and then go into specific components within the Azure Application Platform. We'll spend a lot of time doing demos so you can see the platform kind of real life and understand the value of each of those different services that we offer. And we also have the opportunity of having a customer application that was built on the Azure App Platform, and we have a partner who will walk us through that solution today. Now, just to give me a little bit of understanding, who was in Scott Hanselman's session this morning? Hey, a good number of you. All right, there'll be some of the services that we'll hit on today, things like app service and functions. Those will be covered in this session as well, but we'll get maybe a little bit deeper. At the same time, we'll cover more with regards to our application platform. Now, maybe also, can I get a show of hands? Who's using app service maybe today? Okay, a number of you. Anyone using Service Fabric? Oh, some hands are already up. What about functions? Okay, that's a new technology. All right, great. So we're going to provide you with a broad overview of the application platform, and then what we'll do is point you to dedicated sessions on these topics as well so you can learn more. So with that, let's dive right in. So first, the cloud is changing expectations. Your customers are expecting more, your business is expecting more, you're expecting more. But the reality is that there's no better time to be a developer. You can now build and compose applications that were just never possible before the cloud. And I'm sure you feel that every day. What's also exciting is that you can get your features, your new innovation to market much quicker with the cloud. The cloud is really disrupting how applications are built and how they're made available in the marketplace. So I just want to start by showing you these 4 images. Anyone want to call out what they stand for or what they all represent? So basically, I think some people were starting to say that, is these are all industries that were disrupted by born-in-the-cloud companies. These were all industries that had been around for decades at a time, but then born-in-the-cloud companies came in, rethought the customer experience, took advantage of the cloud to create new products, new services, create new business models that were not possible before the cloud, and completely disrupted existing kind of industries. And this is becoming the reality for companies today. And it's not just startups or software companies that are focused on application development. It's every enterprise. And when you talk to the senior leaders at any Fortune 500 company, they talk about the importance of the software development and the cloud when it comes to the future success of their company. These quotes, I think, pointed out really well. Based on IDC data, over 70% of CIOs are taking a cloud-first strategy. And what I love about this is that companies are no longer about just that product or service that they used to always build. In Scott's keynote this morning, he talked about BMW. And it's not about building cars anymore. It's about building auto experiences. It's about auto maintenance experiences. It's about taking advantage of IoT and machine learning and advanced analytics to provide personalized experiences to their customers. This is how all kind of senior leaders are thinking about when it comes to application development. Now, before we go into the Azure Application Platform, I just wanted to kind of walk through a brief timeline of what we see when it comes to cloud adoption, the specific services that our customers have been adopting. And kind of phase 1 over the last 5 to 10 years has been really about infrastructure services around IaaS. And really it's because companies, IT professionals, developers were able to continue doing what you do on premises. You were able to spin up a VM, write an application, deploy an application, and it was very comfortable. It was what you knew how to do in your current kind of work environment. But what we started to hear more and more over the last couple of years from our customers is that we need to focus more than just on efficiency. We need to focus on innovation. We've got to stay ahead of the competition. we can't have delayed time to market. And we therefore are turning to platform services to really speed up our innovation cycles, to really have that DevOps kind of mindset. And what we're seeing now on Azure is over 50% of our customers are using both IaaS and PaaS. And we only expect this number to continue to grow as companies, as senior leaders are focusing more and more on innovation versus just efficiencies. Now, I'm sure based on the people in the room and what you already raised your hands on, you have a good understanding between IaaS and PaaS, but sometimes I get questions, what is the difference? You're using those terms. And so I thought I would just lay out this very basic diagram that's sometimes helpful for our customers. And basically what it says is, there's goods about all approaches. It really comes down to the level of responsibility that you want to have with regards to your application development and your infrastructure management to decide which type of kind of infrastructure you want to take advantage of. So if you first, on the left-hand side, want to focus on on-premise experiences, your IT organization manages it all, from the underlying network, the hardware, all the way up to the applications that you actually run. But if you go into the cloud, you kind of move into the IaaS, or infrastructure as a service. Now the cloud vendor takes care of all that underlying fabric, the hardware for servers. You don't have to manage or maintain or order that stuff. What you now have access to are VMs. And they're basically like empty computers with operating systems that now you're responsible for managing, updating, patching, but you can put whatever you want in those VMs, and you can decide how much you want to scale them out, however you want to deploy them. It's all up to you. You're responsible for everything at that VM layer and above. Now, if you move then next into PaaS, or platform as a service, now that underlying infrastructure is taken care of for you. You no longer think about operating systems and if they're up to date. You don't have to think about things like patching or scaling out your application or load balancing. You don't have to think about backup and recovery. That's all handled by that infrastructure. And developers really like this type of platform because now you can focus on your code. You don't have to focus on the infrastructure, which is not where the innovation is taking place. And of course, I just want to hit on SaaS because that's when you have no responsibilities. That's when the vendor takes care of everything up into actually running the application. So that could be Office 365 or Salesforce, where you as a customer just put in your credit card and sign up, and you can take advantage of that application. But you don't have to run it or be accountable for anything related to that application's capabilities and kind of service experience. Hopefully that aligns with kind of your definitions of these offerings. Oops. Oh, I think I pushed the wrong button, or not. Okay, great. I often then get the question, okay, I understand PaaS is valuable and I can focus more on my code, but what are the real business benefits of it? And so we partnered with Forrester and we ran a report where they talked to 8 of our customers, and they said, okay, you've been using Azure IaaS. You now started building applications using Azure PaaS. What kind of business benefits did you realize? And based on talking to these customers, came back with some pretty significant results. And those results were more than a 4.5 times kind of ROI. And what's really interesting about this report is that the benefits came on both sides, both reduced kind of IT infrastructure or administration time, but the true value and the value to the business is around faster kind of time to market, faster time to innovation. And so over 50% improvement in getting your applications to your customer is faster. And then also about those iterations, continuing to improve that application as you learn while your application's in production, you get feedback from your customers. So this kind of data is really helpful for us to really understand the impact of using PaaS. And I'll provide a link to this report later on in the presentation. So what is the Azure Application Platform? I'm sure you guys have seen all kinds of different maps of all the various services on Azure. It can be a bit of an eye chart, but we want to hone into really the application platform. But before I go into it, I want to very clearly cover that, of course, Azure ships and offers a world-class IaaS platform. So if you want to use virtual machines where you're responsible for the storage and the networking, you can build your applications that way. You can deploy them that way. We also support containers, so you can package your applications applications in containers, and we also even have services that allow you to manage the orchestration of those container-based applications. We'll talk about containers a bit at the end of the presentation because it's really tied to a lot of these application models. But for right now, I'm going to dive right into more of what we define as our application platform or our PaaS-based services. I'm going to provide a quick overview, and then we'll drill into each one of these, and then we'll go into some demos as well. First, Azure App Service. Saw a lot of hands raised there. This is our one of our most popular Azure services, which allows you to easily create enterprise-grade web and mobile applications, an e-commerce site, a line of business application. You can really quickly build, deploy onto App Service. And the key thing is that application platform is fully managed for you, and we'll dive into some of those capabilities in just a bit. Next is Service Fabric, and this is our prescriptive application platform for microservices. And it's really designed for the kind of applications that you may need to build that are massive scale or kind of need to be available 24/7, have multiple components, a much more complex application. You can get a lot of value out of Service Fabric if you're trying to solve some of those problems. Next is Azure Functions. So Azure Function is our event-driven compute kind of offering. Often it's also called serverless compute in this environment, but it's really what it's about is your app components are kind of waiting to respond to a certain event. And once that event happens, it runs a very specific task. And that task is some code that you have written, a function, to take place. And this all happens on top of serverless compute. So you're not responsible for any of the underlying infrastructures, any of the VMs. You're only responsible for writing and maintaining that code that is triggered based on an event happening. Now I'm going to walk through some examples of events, but an event could be tied to an IoT event, maybe a gaming event, maybe something that's happening in your web or mobile application. But we'll give you some examples in just a bit. Cloud services, another very popular Azure service or first PaaS offering that we brought to market back in 2010. And it was really designed to enable you to take advantage of your existing frameworks, maybe your apps, your line of business apps you'd already developed, and be able to take advantage of the cloud infrastructure, VMs and storage and networking, but at the same time not have to deal with that underlying infrastructure and the kind of configuration of Windows servers. And then lastly, I just want to hit on that Azure is an open platform. We are absolutely committed to supporting every language, every framework, every OS, every PaaS solution. So our ecosystem builds all types of PaaS offerings, whether it's Cloud Foundry from Pivotal, whether it's Red Hat and OpenShift. We have lots of PaaS offerings that we make it very easy for you to take advantage of right within the Azure platform. Now today we're going to hone in on just a subset of these services because we don't have a ton of time, but we're going to talk about App Service, Service Fabric, and Functions, and then a little bit on containers. But we have lots of other sessions that drill into all the other topics as well. So first, App Service. I already mentioned one of our most popular services in Azure. Over 1 million applications are running on App Service today, over 350,000 active users of App Service. It's a very kind of easy way to get up and running, take advantage of the Azure platform for building web and mobile applications. And there's kind of 3 primary benefits of why our customers say they take advantage of Azure App Service. And it comes down to enterprise-grade application support. It's a fully managed platform, and that it provides a high productivity environment for development. And so what do I mean by all that? Actually, you probably could tell by a lot of those images what I mean, but such a common scenario we often hear from our customers is, okay, I want to deploy my application on App Service, but I have data or systems that I want to leave on-prem, and I need to have hybrid connectivity. Azure App Service makes that kind of scenario super easy for you. Another thing we often hear from customers as well is that, deploying my application into a shared multi-tenant environment just doesn't work with our security requirements. So things like Azure App Service environments allows you to have an isolated, dedicated environment for deploying your application. These are just some examples of enterprise kind of capabilities that we make available within the platform. And next is about a fully managed platform. Kind of already talked about this today, but things like OS management, patching, upgrading, those are all taken care of by the platform. But also you have capabilities like auto scale and load balancing. So when a bunch of traffic hits your website, App Service will scale out for you, and when the traffic goes away, maybe the campaign is over, it'll scale back in. You have things like backup and recovery, so you can always ensure the availability of that application. And finally, it provides a high productivity environment. Right within Visual Studio, you can deploy your applications to App Service. It's all integrated with code repositories, whether it's VSTS, whether it's GitHub or Git, and you can do continuous integration and continuous deployment workflows. We also have templates right within our app gallery, so you can take advantage of third-party templates for quickly building your applications. And finally, I thought I would just hit on our staging and deployment capabilities. So we have deployment slots that Jeremy will show in just a minute, which allows you to have multiple versions of your application. And what you can do is, kind of work on one version of that application. Maybe that's in a testing environment, and when it meets all of those requirements, you can just push a button for it to move into production, and App Service will take care of all that underlying infrastructure, things like DNS hosts, kind of making those changes for you. It's all kind of happens right out of the box. So you can really focus on your code and not the underlying infrastructure. And I already hit on App Service is great for building web and mobile applications. I've kind of talked a bit about some of those web-oriented capabilities. There's lots of mobile services as well, things like offline sync or push notifications makes it really easy for you to create some mobile backends. At the same time, we have the ability to create workflows within your applications very easily with Logic Apps. And finally, with API apps, you can take advantage of out-of-the-box connectors to other SaaS applications or build your own APIs and host them on an App Service. Lots of ways to really build and take advantage of your application development on App Service. So the last slide I'll show you before Jeremy jumps in is what's also great about App Service is it just works really well with all the other Azure services. So, you've got your application and you want to connect to a SQL database, you can just automatically do that and, takes on all of your application settings, you could say, for a web application. At the same time, you want to add authentication to your application. You can, with just one click, hook up Azure Active Directory and use that as a way to be able to manage authentication in your web and this mobile application as well. And finally, there's even things like out-of-the-box integration with App Insights. So if you want to understand, is your application running? Is it available? Is it performing? How's it being used? App Insights will collect all that data, and if there's a problem in your code, you can quickly identify that and be able to address it and get your application back into production. So with that, I am now going to turn over to Jeremy to give us a demo of App Service.
Excellent. Thanks, Nicole. So I'm just going to switch over to my computer here. So you can see here we're in Visual Studio, and as I'm sure a lot of you in the room are, whether you're a developer or an IT pro, you probably live inside of this environment for coding if you're kind of working with .NET or Node or some of the other open source technologies that are supported in here. One of the big things that people aren't aware of is with the Visual Studio Community Edition and with Professional Editions, you can install the Azure SDK. And what this gives you on the left-hand side is the ability to navigate around your cloud and explore the different areas that you have within it. And you can do things like filter by resource groups, or you can actually also filter by even resource types. So for instance, if I'm looking for, should let that load first. If I'm looking for a particular web application, I can scroll through and have a look and see all my different web apps that I have. But the thing is, you might over time get lots and lots of resources that you have. So I can jump in and go to my resource groups and say I'm working on this particular opportunity here at the moment. I can see all of my Logic apps that are bundled with that particular sample that I've put together. I can see the App Insights configurations, all the queues, all the databases, and the web apps, and maybe even the API apps that I've got deployed in here. Now, some of the quick tips from this perspective is if I scroll down, for instance, to the web app here, which is indicated by the web icon, I can immediately click and jump and go straight into the blade for the app service in the portal. So maybe it's just a little bit quicker to jump through than it is to navigate through the portal in the browser, but that allows me to log straight into the app service configurations for that particular web app. Now what I can also do is if I scroll, or tab back, sorry, I can jump into that in the browser. One of the things I find as I've got more and more web apps in Azure, I often forget like the URL that I'm using inside of each environment. So what the SDK allows me to do with that Cloud Explorer is jump straight into that environment and test that. So 2 really quick tips there that I find extremely useful when it comes to doing this. Now the big thing as well as a developer is how are you going to get things in the cloud? Now typically you'll develop locally. So you'll be F5ing and debugging through your code and stepping through it. One of the big things with app service is the speed that you can push this into an app service web app so that you can maybe share it with your manager or share it with peers to get them to test things without having to have access to your machine. Because we all know networking can be a problem and exposing things on ports and so forth across your network is hard, especially if they're remote. And so it's very, very easy to publish. If I just right-click on the web project there, which is an MVC project, and I go up to my profile, essentially I have a few options. Now, my IT guy might give me a profile which I can download from the App Service Blade settings. Or if I'm logged in, I can just click on Microsoft Azure Service. I'll be logged in up the top here as my account where I've got all my subscription information. And then you'll see that I actually have the ability in here to select my web app. And I'll come back to this in a minute, but you'll also see I have the ability to select a staging slot too. And I'll just zoom in there so you can see that. So essentially, I can pick where I want to push this code to test it. And then I'll be able to provide that URL to anyone that wants to be able to do that. And it handles all that configuration for me. Visual Studio will nicely go away now and give me a nice verbose logging on exactly what's going on, package it all up, and push it up into App Service. So it really hasn't changed your workflow much if you're a developer right now where maybe you're FTPing this somewhere, or maybe you've got a network share to an IIS server sitting on-prem or in your data center to be able to move those files across. Now, I know a lot of you put your hand up for app service stuff, and that might be very apparent. But it was really just for the benefit for the guys that maybe have not used app service yet in the Azure land. Now, if I go back to the Blade where I had all of my configuration for this particular web application, some of the first things that you'll start using is those deployment slots. Now, what a deployment slot does is essentially allows me to deploy an instance of that web app that you might have new content in, maybe some code changes, and you want other people to test that. And it can have its own individual settings. So if I click on that particular deployment slot instance I've created here, with every single web app that lives within App Service, I have the ability to have application settings, which are essentially environmental settings that traditionally as a .NET guy you would put in the web config and use the code lines to pull that configuration entry out. But I actually have the ability, if I scroll down here, to see all of those environment settings that I've got for this particular instance of this deployment slot. So I could, for instance, have a staging database set up that this web application points to, and allow my users to test with staging data and not my production data in SQL. The nice thing is, though, that when I want to, maybe we've got approval from my boss or boss's boss, and Nicole's gone, yep, we're going to push this live, I have the ability straight from this interface to click swap. And inside the swapping here, on the right-hand side, I can say, I want my staging, which is the source, to flip to production. And Zoom, it's really not playing nicely with you. And essentially what that will do is it will allow me then, if I click OK, to flip those over. Now imagine what that's doing in a production environment if you didn't have this kind of configuration. I'm changing name hosts, I'm doing DNS changes, I'm making sure the IIS website's warm. All that's happening for you on this deployment slot. So as an end user, I won't see any difference at all until that new staging slot has been switched to production, it's warm and it's ready to go. And you can even say things like run some tests against this before we flip the switch as well, using either standard perf tests, which have various criteria, or even kind of Visual Studio web tests, which actually might run through some steps to have some data plugged into the various different use cases you have to make sure it passes before you flip it. The nice thing is, if you miss a use case or you catch something as a problem, you can very easily swap this back and flip the old production back into being production as well. So this can all be done in a matter of seconds here between your app service instances, which is a really neat bit here. Now, in addition to that, what you'll notice on the sample app that I just showed you, if I go over to my claims, is I'm actually logged in as a particular account here. With App Service, you get very, very easy ability to go and configure what authorization and authentication you wish to have for each web app that you publish. So for instance, you'll see in this instance that I've actually got this configured so that it's logged in with Active Directory. And then on the right-hand side here, if I scroll down, we have this notion called Express on the right-hand side there. And what that allows me to do is very easily, with a few clicks, configure my application so the next time I hit it, I'll have to have sign-in available on my web application, which then locks it behind an authentication wall. There could be Microsoft account. It could be your Azure Active Directory. So if you're already using Office 365, you've already got Azure Active Directory in your environment, you'll be able to lock your own web applications behind this with a few clicks, which is extremely useful. Now, in addition to that, if I go back to my claims and just click search here, just to show you what this application is actually doing, and I go into this in a lot more detail in a mobile session that I have on Wednesday in the morning at 10:15. But this one is a scenario where I'm taking photos of an unfortunate car crash that I had. It's tracking kind of the location of where I took those photos. It's scanning in the license information. It's using cognitive services to get the number plate out there, the license plate out there, and store it into this system. And I have the ability in the top right here to either approve or reject this claim. Now, this MVC application, we've pulled it apart a little bit and started leveraging functions, which I'll talk about in another demo later on in this session. But this just gives you the idea that this application is being run and there's lots of moving parts. Now, as Nicole mentioned, there is a great way of, if I go in here, of configuring application insights for my overall solution, which my functions, my web apps, my API apps, my logic apps can all post and point to and give information for. So in this instance, if I click search here, on the right-hand side, that's going to log absolutely everything that's going on in my environment for that particular solution. And if I scroll all the way down to the bottom here, if I load some more maybe, you'll start to see that there's some exceptions in there. And so if I look into the exception, and I've already kind of grabbed this correlation ID, I can see exactly what happened, what the error was, without having to have my application in debug mode. Now, the benefit of that is if I grab the correlation ID from the top here, and then I go over to my application insights, more of my dashboard, with this query, and yes, it is available online to go and copy and paste in, and you just add this correlation ID in here, I can start to see all the different activities that are happening for that one approval process that I have in my web application. And so I can go in and see kind of verbose log information as well as exceptions. And so it doesn't mean that I have to go download these from a log folder somewhere on storage, or have to attach a debugger into my web app and run through that thing and replay it. I can see everything that's been happening. Now, in this instance, this is in a staging deployment slot, but even in production, you can have app insights on and start to see exactly what the paths are going through your application, and which really helps when you're trying to debug something live. Now, if I kind of just walk that through again, the other benefit of those deployment slots is when I create a new one, what I can actually do is when I click add, I could say maybe there's a bug finder, and I can actually pick, I'm going to use the other zoom. I can actually pick which one of the web applications I want to clone. And so I can say, okay, I want a complete copy of the instance I've got, and in a matter of seconds, I can hit that new web bureau and test that application, hook in some app insights. And what I can also do, if I deploy the debug symbols to it, is if you go back to the Cloud Explorer here, if I just minimize this, I can actually select my web application, and you'll see down the bottom here, I can actually attach the debugger. Now, in the purposes of times, I'm not going to go through that process, but essentially that allows me to hook into a web application running in the cloud and step through that code. Now, it does lock that web application, much like if you did this on your local machine, but it gives you the ability to test what's running in Azure and step by step go through your code if you've not totally put enough telemetry in your application for logging it to App Insights. And the App Insights is extremely easy to configure inside of Visual Studio. Now, App Service, obviously one of the killer features which Nicole mentioned was this notion of the ability to scale up and scale down your plans. So we have this notion that you choose how big or small you want kind of the stamp to be. So you can pick how many cores you want, how much RAM you like, how much storage you're going to use. And so we have this kind of like sliding scale of how much money you want to spend based on the load you feel like your web application is going to get. and number of slots and so forth. We also have another way of scaling, which is to essentially scale out. And with that, what I mean is, if I scroll down the bottom here, I can actually go in here and just essentially say, this is the number of instances of that one stamp of a web app I want. And essentially, once we get to maybe an event that's happening where we get a lot of traffic to a website, my app instance will actually grow to cater for that scale. And once the traffic's dipped down again, it'll actually shrink back too. And so you're only kind of using the resources that you're paying for the traffic as and when it needs it, rather than in a VM instance where you're kind of spinning up VMs for the maximum amount of load you need. And a lot of those virtual machines might be cold for a long time because it's not having the traffic load that you require. So that app service is a great way of kind of handling load at scale on applications, but treating that on an individual web app status. So there's a bunch of other features in App Service. If you go to azure.com and App Service, you'll be able to see those. But one of the things I wanted to show now was we have another app within App Service called Logic Apps. And what Logic Apps does, if I go to my Logic Apps resource group, one little tip for Azure people, start using your resource groups to bundle all your different moving parts together so it's easy to kind of try to navigate through. This Logic Apps demo is really taking this notion of, I don't want to write so much code. I'm connecting to a bunch of different services. I've got this notion of a workflow. And a picture tells 1,000 words. When I come into my Logic App Designer here, essentially it's going to show me that flow in a visual way. And this flow, what we're doing is we're triggering on a Salesforce contact card being created that we're going to send an email to an approver. And if I expand these particular objects, you'll see here that we're triggering on a Salesforce contact. I'm going to check that every minute. In my email, I'm essentially going to say in the subject that there's an approval request for a new contact and put the parameterized bits that came back from Salesforce into that email along with the body. And in this case, I'm emailing it to my demo account. And I'm going to give some options. I'm either going to give an add to dynamic CRM option or a post to Slack. If I scroll down here, you'll see that there's a condition. And the condition is well, what did they click in that email? And so if it's equal to add to dynamic CRM, I'm going to run this create new record in Dynamics. And I'm going to create a new contact, and I'm going to put the last name inside that Dynamics contact. So again, I've not written any code yet. This is all using out-of-the-box connectors with Logic Apps. If I scroll down a bit more, you'll see that we have one for Slack too. So you can see here, I'm going to post, if I say no, to the general board, and I'm going to put this message inside the Slack information pane. So again, I can drag these actions on. So for instance, if I wanted to create a new action in here, I would just click Add an Action, and I can start searching. So I could be like, if I could spell, let's go look for the Slack one. Maybe I wanted to post 2 messages on here. I'd be able to do that. So there's plenty of connectors in there. I'd encourage you to take a look. I'm just going to essentially discard those changes because I just want to show you that working. So what I'm going to do is jump over to my Salesforce contacts here. Again, I'm not very familiar with this, but I know enough to know how to create a new contact in here. So I'm just going to create just that one like that. And click Save. Now that's going to go and trigger that Logic app. The nice thing about this is that when I go back to my overview here, we'll actually be able to go to the overview inside the Logic Apps blade and see them running. So I can click on the running here, and I get a visual designer of that instance of the Logic app actually executing. So I can see for any instance that's running, whereabouts in that activity that it is. So in this case, it's checked that mark to say that the object in Salesforce has actually been created, and it's waiting for a response on the email that was approved. So if I go over and wear one of my other hats here, remember which browser window I actually have my other hat in. There you go. I feel a bit psychotic with the amount of profiles I've got running right now. And you can see here that I can either post to Dynamics or post to Slack. So if I click post to Slack here, it'll bounce into a Logic Apps thing to say, thank you for your response. And then if I went back to my Logic app and just refreshed that, we'll actually see that that's actually completed. And if I close that out and go back into here, now we'll get all those markers saying that that's actually completed all the way through that flow. while that's loading up, I'm just going to jump back into here, and you'll see that we've got the different content things going through. Now, I'm not going to wait around for that to show up, but the Logic app is coming through. If you scroll down the bottom here, you'll see that that's ticked and it's posted it through there. So let me just refresh the Slack window. Okay. Well, I got a tick. You'll have to believe me that will work. I'm not going to troubleshoot why they didn't work right now. But essentially, you get that visual design that allows you to show all those different flows. Now, if I'd clicked the other button, it would have posted into Dynamics and created that Dynamics content card directly inside of the CRM. This is really useful for business users that want to be able to build out business workflows for approvals of all sorts of different systems that you can connect to. And so this is a really powerful way of kind of empowering your business users, but also developers to kind of get involved too. We can export these things as JSON files and import them into other instances. I can deploy these via continuous deployment as well as a pro developer. And so it makes it very portable to push around different Azure subscriptions or even to copy Logic apps and duplicate them for other typical scenarios. And you start to get this like toolbox of reusable features. So with that, I'll hand back to Nicole, who will go to talk about Azure Functions.
Thank you, Jeremy. Okay, great. Actually, before we go into Azure Functions, we're going to invite Mitesh on stage, please. He works for New Signature, and they're a partner of ours, and they built an application for Met Office. And he's going to walk through how they took advantage of our application platform to build this solution. So we'll get a quick overview of the problems they were trying to solve and a little bit of a demo of that application, and we can kind of go from there. So you can just click here.
Hello, everyone. Can you hear me? Cool. So slide says, I'm Mitesh, who work for New Signature, based in the UK. We were the Partner of the Year in 2014 and US Partner of the Year 2014-2015. Our primary focus is around Microsoft Azure, Office 365 and the Enterprise Mobility Suite. So we're here to talk today just to show you what we did for the Met Office, which is the official weather service in the United Kingdom. They store weather observations from all around the world, and they're looking to expand. They were a government organization previously, and now they're looking to use the data that they've collected to disseminate it across the world to other weather organizations around the world, which we'll have a look at shortly. So what they were doing, they were looking for a platform that would enable them to get change and modernize the way they do things and get to market really quickly. And the things that they were looking for a platform that would help them get the best total cost of ownership as well. So. Let's get that on working. Cool. So we've got a little video here just to give you an idea of their requirements and how we went about the project.
The volume's not working. Oops.
Is the sound?
Okay. Can you turn up the volume?
The Met Office represent a class of organisations that are at the very cutting edge of technology. So to that extent, we've got one of the world's largest supercomputers downstairs, and we contribute billions of pounds a year to the social and economic advantage of the UK by delivery of insights in weather and climate.
Increasingly in the last few years, we've started to see many more weather observations being taken by citizen scientists. And so we set up WOW, which is the Weather Observations website, to really try and make the most of those observations and bring those into our operations. When we set up the WOW Engine project, part of it was to look at where is the best cloud provider available to us for what we want to do. We did a fairly rigorous evaluation of the different offerings that were available, and we decided to move from our previous cloud provider onto Microsoft Azure.
The commercial advantage to selecting a platform as a service is that you're literally not having to pay developers to develop chunks of functionality that already exist, and that chunk of functionality will be serving other people, so is likely to be of higher quality and therefore more affordable, as well as being available. The Microsoft decision for WOW was based in part certainly on the economics, and the big driver for the economics is what we call the total cost of ownership. That is the all-up cost associated with the lifetime of the features and functionality. And the Azure platform scored very highly in our analysis of that metric.
I'm really excited about the WOW engine. It offers a massive opportunity both for us as an organisation and also for members of the public and other citizen scientists to really start to put their data to really good use.
Okay, so hopefully that gives you a little bit of an idea about the business requirements and what they were looking to do and why they chose Azure. So if we look at the architecture here, we'll just draw your attention to a few of these. So these are all elements that we can hook into in the Azure PaaS environment. So if we start on the left-hand side, they're using weather stations that they currently have, and we're pumping data into the IoT hub, which we know that can handle millions of device transactions, and that can hold that data, which then pumps it into web jobs. We've also got the option for users now to enter data via the PaaS web app APIs that we've developed. We're also looking to expand that. So what we wanted is a platform that can scale to go from thousands to hundreds of thousands of devices. So they're currently looking at things like automobiles or cars, to be able to take data from cars such as rainfall, humidity, and plug that into this platform as well. Other areas to note are, say, the cognitive services. So we use some of the vision APIs in there. So there's various things inside that, such as facial recognition, sentiment recognition, and we use the content moderator. So part of the platform allows users to upload images of weather locations and situations. So what we wanted is to be able a way to filter those images without having to write our own code. So we were able to plug into the Vision APIs, and what that does is it scans the images and does a content moderation, so nobody can upload anything inappropriate, really. And it does all that in real time. And so again, as the video mentioned, it's things that we can plug into that's already built. So all this helps us get to market a lot quicker. So those images are then stored in the SQL database, blob storage, pulled out of the service bus queue, and the web jobs, as I mentioned, process it and stores it in the data. In the top corner, we can see the Elasticsearch. So the Elasticsearch started off as an IaaS service, so based on VMs, and then it moved to a third-party web APIs to be able to do the Elasticsearch. So it's evolving. So there is also a feature called Azure Search now. So that was in beta at the time this was developed. So we're looking at bringing that into the environment as well. So it kind of just shows how flexible the environment is. We can use IaaS, other third-party APIs, and the flexibility allows us to integrate with various other vendors as well if we need to. So if we look at that in reverse, we can see how that data is consumed. So you can use the web APIs to pull out that data to do searches for weather observations. And we use Redis cache as well to help speed up those transactions and retrieval of that data from Azure SQL database. And again, we use the Elasticsearch to help with that retrieval. Just some facts and figures here. So we're looking around 10,000 users per day. We're storing billions of observations, and you can see the numbers are going up. We're looking around a terabyte a year, but that's one of the things that we were looking to do, make sure we've got a platform that can handle these kind of numbers up to billions of observations, and that's going to grow. Currently, they're collecting all these observations and retrieving them in the UK and Australia, and they're looking to expand that around the world, and Azure platform allows us to do that and allows the customer to also offer these services to their customers, which we'll have a look at shortly. Okay, so we've got a quick demo of what the environment looks like, and we'll just quickly show you that. Yep, I'll just drag it over in a second. Okay, so here we can see the platform, which is the WOW website, weather observation website. We can zoom in and out of the region. So if we look at, we've got different layers, for example, temperature, photos, humidity. So if we, for example, look at photos and look at our current location, we can see entries that people have put in. So at the moment, there's not so much in this area, but if we zoomed out and if we typed London, for example, and we'll be able to see, if we look at temperatures, we'll be able to see a temperature map. So all this is pulling data from Azure relatively quickly. And then we can see all these observations that have come through weather, and we can specify where they're coming from, whether from official weather stations or citizen scientists, as the video mentioned. So if we just look at everything. I also mentioned photographs, so we can look at photographs from here. If we look at our current location, we can see there's an observation here. And again, that'll give us a quick summary of the environment. We can look at forecasting, and we can also drill into graphs and tables when we view the other ones. We can also enter our own observations, and this is how they would do that. So we pick a location, you can specify a current location, click continue, and upload your data, add a quick observation or a detailed one. This allows people to capture more scientific data. The other thing that we mentioned, so the Met Office wanted to become like an ISV, so they can resell this information to other organizations around the world. So if we look at one of those sites is the BOM website, which is focused in the Australian region. And we can see if we click on this website, which is a slightly different URL, we'll be able to capture readings from there as well. So hopefully that gives you kind of an idea of what the weather observation data is all about and how to capture it.
Sure. Sure.
I believe in the PAS, because they're all PAS elements, so it will be baked into that. Yeah, so Microsoft take care of that, so we don't need to worry about it. Because if it was in IaaS, then we'd have to build all that in, build the patching in the application as well. But as it's in PAS, Microsoft take care of it. I think we'll get an alert if somebody tries to do anything they shouldn't be doing. Yeah. Okay, thanks.
All right, thanks, Mitesh. Yep. Thank you. All right, we are already a little bit behind on time, so we're going to try to save time. We're going to quickly, jump now into Azure Functions. So we discussed them before and said Azure Functions are kind of compute, event-driven compute. And so a great way to quickly show you what an Azure Function is and what the types of capabilities is to give you an example. And the example I'll show here right now is a mobile backend where I've got an application that I've developed, and maybe I take a picture with my mobile phone, and once I take that picture goes into blob storage. At that moment, I've created an event. When I create an event, I may want to do something like create an Azure function. An Azure function could run a specific task that I defined for my application. In this case, I wanted to divide or create multiple versions of that image. I want a small version, I want a medium and a large, maybe a thumbnail, maybe a large image of that photo for download. So what I'm creating is a specific task that happens when an event happens in my application. And what's great about it is it doesn't happen within the mobile app. It's happening as a background task. So it's easy for me to manage, easy for me to maintain. I think your question right there of, wow, what if there was a virus and something that was uploaded, an image, or maybe, what if someone uploaded an inappropriate image? You could use something like a function to, once that actual app or that image was installed and landed into blob storage, you could use cognitive services, for example, to evaluate, what is that image? Is there anything inappropriate before it actually goes live on a website? So there's lots of interesting kind of tasks that you can take or you can build by taking advantage of functions. So Functions is a new service. We actually just released it on Azure, and it's currently in preview. But there's a variety of different benefits of it. One is that it's serverless compute. You do not deal with any of that underlying infrastructure. You basically just write the code and you manage the code of that specific task that you want done based on an event that you define. And what's great about it is that it automatically scales. So let's just say a bunch of images go into that photo library, it will scale out to handle that capacity. But let's say, early tomorrow morning, no one's uploading any files, it'll scale back down. And the key thing here is you're not paying for VMs that are being spun up and just kind of sitting idle. You only pay for the actual execution of that function. So it's a very affordable way to run tasks related to your application. It creates these mini tasks that are tied to your application. It's really designed to also accelerate your application development. You can use the skills you have, use the tools you use today. You can write a function in Visual Studio. It's all connected with CI/CD, so you can continuously update and improve that function. It's really designed for efficient app development. And then finally, one of the most valuable components of functions is how it binds to other services. So what's great about functions is that you can connect to other Azure services or to other third-party SaaS applications. But you as a developer do not need to understand how data goes in and out. You don't need to understand the kind of details within that service. You just write the tasks that you want to kind of happen, and the translation layer is all done by functions. So it makes it a very efficient way to actually build them. And it makes it also easy for you to switch across services in a very quick and easy way. So we're going to jump right into the demo of Azure Functions so you can see it live, and then we'll flip into some other areas of the application platform.
Great, thanks, Nicole. So best thing with the demos was that Logic App did actually work. I just didn't wait for that email to come through to click it. Only caught that was paying attention. I did actually go through and post that in there. But with Azure Functions, as Nicole said, it's very, very easy to run. If you go to azure.com right now and go to Products, and you'll immediately be on Compute and you click Functions, you'll be on the Azure Functions page. And when I click Try it for free, you get the same type of experience that you would get essentially if you went into the portal and did it through a blade. So I'm immediately in. You'll see that at the top here you get an hour worth of sandbox. I ran this earlier on. But this allows you to try functions without even having an Azure account whatsoever, and you can kind of go through writing some code and various different triggers and so forth. Now, for me, if I go in here, I can very easily go and create a new function. I'm going to go and create a new generic webhook in Node here. And if I scroll down and just click Create, what that will do is it's going to create me a new generic webhook in Node, which is called JS2. And you'll see there'll be some code. And this is the code, kind of a template code that you get with a function. You'll see at the top here, because I created the webhook, that's automatically where I go and grab that URL that I'd call from whatever service I wanted to. But also in my environment, I have the ability to click Run. So you'll see here that I'm passing in JSON, which is first name and last name. And then in my code up the top, if you just had a look at what's going on, we're just creating that message here and responding that as text and posting that as a response on there. Now, with these webhooks, what I can actually do, if I go and create another one here, if I just go Slack poster and click Create, what I can do is I can modify these very easily within the UI. And because I'm in Node, maybe I want to use some libraries. So I've got some files here that I've prepared earlier. And what I can actually do is I can click and drag into that environment and upload that package.json. And that's, in this case, I'm using the SuperDuper Functions class, which is available on NPM. Now, that's not automatically going to load it right now. So what I have to do is go over to my function app settings. And inside of my function app settings, I have the ability to have a dev console. So this would be very much like you were doing if you were using Node on your local machine. And inside here, I can just kind of click on that again. Inside here, I can actually see all of my folders. And you can see here that I can go to my Slack poster directory and see the files that are inside that function. So the function, the index, and the package.json. But I can also do things like npm install commands, which would go away execute my package.json file from my node folder, and then produce those files directly in that location. So if I went back now to my Slack poster function and had a look at my view files, you'll see now that there's a node modules folder that's been created by the npm install. And if I dug into that, you'll be able to see all the files that have been kind of manipulated there. Now I'm also going to grab an updated version of my index.js. If I drag and drop that on, and I view that now, you'll see that it's pulling through some new code. And in this code, what I'm actually doing is I'm going to define this Slack URL. Now, for people familiar with app service, where it's getting that is my environment variables. So if I scroll down here, I can see all of my app settings for functions. If I scroll down to the bottom, much like I showed you in that previous demo, in the app settings, we'll actually have the Slack webhook configured within my app settings for this particular function. And what that means is rather than me having to hard code these things into functions, I can start moving these functions around, reading app settings that within this function app that's been created. Now in this instance, what I need to do to test this is a little bit different to how I had it with my run in my previous Hello World example. So what you'll see if I scroll over here is I just need to change what happens in here. Now I have that code copied here. And I'm just going to copy that, and then I'm going to scroll down to the bottom of this window and just click Run. Now what that's going to do is pass that into my code, read the Slack URL, go and get the Slack body, and then I should get a 200 status message on that. And then what that will do is it will post over to my general channel inside of Slack. Now I did notice that with the Wi-Fi I'm having to click Cancel and click Run twice there for that to work. And then you'll see that something cool happened 3 times because I was impatient and clicked Run a bunch of times. But then that allows me to have an embedded hyperlink in there, which if I actually click that, would go through to that Azure Functions URL. Now the neat part about this is, from a functions aspect, is that webhook can be called. You don't have to click the Run button to run it. And we showed you earlier how you can actually go into, say for instance, your App Insights. And with App Insights, we have the ability to create alerts. So I could have alerts, for instance, on things like if there are 5 server exceptions that happen inside of my application within a certain time box, let's create an alert. So I can go and create one here. It'll select which web application I want my App Insight to go on. I can say maybe this is my oh no name. And then as I scroll down, I can pick, say for instance, failed requests. And I could say maybe that if there's greater than 1 failed request that we trigger this alert. And down the bottom, essentially all I do is post that Azure Functions webhook directly in here. And now I can handle all sorts of different things from that custom function straight from within my environment. So it's a great way of expanding and hosting code in a very finite, unique, discrete unit within my function app and have a collection of these based on kind of app insights. Other scenarios we're seeing right now are things like having a dynamic CRM context created that triggers a function that maybe does something that Logic Apps can't do because of it doesn't have the activities yet inside of Logic Apps. So you can go that little bit level in code rather than dragging and drop on a designer. Again, giving developers the choice of which service they're going to use, whether it be Logic Apps or functions. Now, 2 other things. In my sample demo, which I'll go into more in our mobile session, we actually see here that if I look, we have various different functions, auto-approve, claim, handle, manual claim. Those functions are actually in a Visual Studio project, which is hooked up and binded by continuous integration. If I go over to my function, this particular function app, you'll see within my functions here, all of those functions are listed there, but they'll be in read-only mode. So this allows me to be working locally with my function, writing the code, committing it to GitHub, checking into Visual Studio, and automatically pushing those changes up into my function app, and then having those things available. And again, we can even use deployment slots in here to have staging functions and production functions as well. So it gives you a lot of flexibility to handle kind of discrete code in a very quick way within a function, rather than kind of tightly coupling all of your business logic into one giant mammoth web application. You can start breaking your application out into essentially microservices using Azure Functions. think there was a question there.
This is very similar to the trigger functionality within the SQL Server. It's really cool, by the way. Is there anything coming or maybe already exists to help us manage trying to figure out what exactly will happen when a file is uploaded if there's hundreds of functions deployed?
Yeah, good question. So this is similar to SQL triggers, where you could script based on rows in a database table. But with all these kind of functions lying around and attaching to storage events or Salesforce events, how do we handle that? How do we manage that? We're actually working right now on a designer that gives you a visual view of all the functions and how they connect through to all of your services and third-party services as well. The real benefit of this is that inside of these integration pieces, I have the ability to define triggers. So in this case, it's an HTTP trigger, but I might have something where it's popping onto maybe an Azure storage queue. And so I have the ability at scale, if I have like 10,000 files go in, then maybe the event just pops something into a queue, and my function is triggered from the queue rather than the event in storage. So if anything goes haywire with your function, your queue is your kind of your transactional way of handling the load that's going through. And that's the best practice that we recommend with these things, and is actually what this is used in this sample hero demo that we'll go into more detail about later in the week. So hopefully that gives you a good example of functions. Functions.azure.com, you can get started straight away with an hour demo of it.
He's jumping to my CTAs. We're not there yet. All right, we are crazy behind on time, so we're going to really jump quickly into Service Fabric and microservices-based architectures. But what I thought I would do first, because microservices is still kind of in a nascent stage, and there's a lot of questions about, why do microservices exist and what kind of problems does it solve? And this is what this slide is trying to capture. These are the common kind of pain points we often see with monolithic applications. When you've got a big, large application, it's complex and difficult to maintain. For example, you have to fully redeploy that application if you make a change or an update. That doesn't really support that agile environment, that environment of continuous deployments. Really slows an organization down when it comes to innovation. Also, if you have different layers in your application, let's say your middle layer versus your web layer, and maybe they have different scale requirements, you kind of don't have that ability to decouple them all. You have to just scale it all in the same way, and therefore it's not an ideal mechanism for having the scalability of your resource and utilization of your resources. And finally, down to application reliability. If there is a bug in one area of your application, maybe in the middle tier there's a memory leak or something, that could take down the entire process, if not the entire application. So your application overall is more susceptible to failure, which has therefore led to new application models, or this concept of microservices, which is all about creating these small single role services. As you think of something like an e-commerce website, each service that you build, maybe one is the shopping cart, and one's the order transaction component. Another part is the invoice creation. And each of these services are developed uniquely, they are managed uniquely, they are versioned uniquely, they are all separately handled. And the way that they work within a broader kind of application model is they talk through API contracts or API calls about how data should be shared or how systems should be talking to each other. But this creates a very kind of different model for application development, where you've got all these fine-grained functions or kind of service types, but then they are loosely coupled with the kind of API constructs. I thought I'd just very quickly show you the difference of kind of scaling out a monolithic or a more kind of three-tiered application versus a microservices-based application. So in a monolithic application, you've got your data, your business logic, and maybe your web tier. If you want to ensure that you have high scalability of it, you basically clone a version of that application onto multiple servers or VMs or wherever you want to deploy that. But in a more microservices type of approach, you may have multiple apps with all these discrete, individually created services. And when you want to scale it out, you can scale it out broadly across a cluster, and these services can cross over into various VMs or servers. You even have services from one app being in the same kind of VM as services from another app. It doesn't matter because they're all isolated. They're all individual kind of wholly constrained applications or services. And there's lots of ways to build microservice applications. It is early days. I wanted to just show 3 options so you kind of can think through the different approaches as you think about the value of microservices infrastructures. One is what we call microservices in the wild. This is basically build your own, take the best of breed of all these open source capabilities and tools and solutions to build your own customized microservices-based application. Many startups, or let's say a Netflix, they really build their own custom microservices-based application platform. We just showed you functions, and actually functions, as Jeremy was highlighting, are being used in this kind of microservices mentality because you can create these discrete kind of tasks that operate outside of your actual application. And then finally, we have a prescriptive application platform for microservices, which is Service Fabric. And I want to actually jump right into a slide about what Service Fabric is, and then allow you an opportunity to get a demo of that as well. The key thing here is Service Fabric is a technology we built over 10 years ago within Microsoft to basically build and run microservices-based applications ourselves. So SQL DB, DocDB, Skype for Business, Cortana, Intune, they all run on top of Service Fabric. And what we took is we packaged up this actual infrastructure to make available to our customers, to our partners, to build your microservices-based applications. And this is a very kind of opinionated framework that helps you with things like lifecycle management, things like ensuring your application is always on. Let's say there's a failure or a bug in your code, it will do self-healing or rollbacks so that your application is never down. It's integrated with DevOps tools so you can constantly do continuous deployments and continuous integration. You have auto scaling based on the needs of your application. It runs on both Windows and on Linux. Just a couple weeks ago, we announced the preview of Service Fabric running on Linux. We also allow you to deploy it anywhere. So you can deploy it on-premise, in Azure, even in other clouds. So it really gives you a portable model for how you build these applications and deploy them. Just today, we announced that Service Fabric has GA'd on Windows Server. With that, I'm going to quickly hand over to Anand so he can give you a quick demo of Service Fabric.
Thanks, Nicole. So like Nicole said, Services Fabric is a prescriptive platform from Microsoft for building microservices. What you're seeing here is Fabric Explorer, which is insight into the Fabric clusters. You see that there are 3 applications deployed: Cluster Monitor, Visual Objects, and Word Count. Of interest to this demo is the Visual Objects application, which consists of 2 independent microservices, the Actor service and then the Web service. What we're going to do as a part of this demo is see this application, which is Visual Objects, like I said, composed of 2 microservices. And one of the promises of microservices is that you should be able to independently manage, version, and scale each of the services without having an impact on the other. So if you go back to the Explorer, you see that there are 3 nodes to which the microservice application has been deployed to. And if you expand out, the application Visual Objects consists of 2 microservices, the Actor service, which you see is a stateless microservice, and hence it has the Actor microservice is a stateful microservice, I'm sorry. So it's running on 3 replicas, which are primary, and 7 replicas, which are secondary. And if you look at the Web service microservice, that's running on just 1 instance, and it is stateless. So to show you how you can independently manage versions, I'm going to open up the app in Visual Studio. And there are 2 publishing profiles, which means you can either publish this application to the cloud or you can publish it to your local machine. Like Nicole said, it's available on Windows and Linux. Linux in preview, Windows is GA. And I'm going to make a little change to the application just to change the way the shapes are moving around on the screen. I make the change. I save the application. And here is the key part. When I actually edit the manifest version that I'm going to publish out, you see that this application has 2 services, Web service and Actor service. I'm going to change just the version of the Actor service without affecting the version of the Web service. And I'm going to deploy this to the cloud. So I say publish. And by default, it's going to go to my cloud account. And I'm going to upgrade the application, just 1 service of the application from version 1 to version 2. And I hit publish. And as I go to the Fabric Explorer, if I look at the Visual Objects application, you see that the actor service is active. The web service is also active. And the upgrade process should have started. So what should ideally happen here is that these are the different replicas in which the actor microservice has been deployed to. And this is gradually going to go from red to orange to blue. Red means it's going to bring down a couple of replicas on this cluster. And traffic is still not affected because it can go to the other replicas. And then after the replica has been upgraded, traffic will resume back on the main replica, which means that you have 0 downtimes, right? So you can run your mission-critical banking applications, core e-commerce applications without having an impact to your business. As you can see, it's moving from red. Soon you will see it's orange. So as these nodes are brought down, traffic is going to be redirected to other nodes, and you're not going to have any downtime. That's one of the promises of Fabric. So, over here.
Great. OK, we're because of time, I think we're going to flip back over. OK. So we actually have a whole nother section, which we're not going to, I think, be able to dive super deep into. It was about containers. So a common way to package and deploy applications in a kind of modern environment is through containers. And how many people are using containers in your application development today? OK. Is it more in dev test or production environments? More dev tests. You know, right now, containers are very much being adopted and leveraged by developers because there's a set of challenges that you face with regards to, you know, building and testing your applications maybe on one OS, but then it's deployed into another version of that OS and something breaks, or maybe you know, there's some kind of challenge that you're faced with regards to the underlying infrastructure. Maybe the environment that you devved and tested in was a different kind of network topology, security policies, storage, you name it. But then when it goes into some kind of production, something breaks, something goes wrong. And this is leading to this broader goal that developers have, which is like, I just want to be able to package up my application along with all of the dependencies, the binaries, the libraries, the config files into one nice package and not have to deal with that underlying infrastructure. And this is driven to a much kind of broader effort with regards to this kind of the coming of containers. And the other thing is people ask, why not just virtualize? We have virtualized machines. This is what we use today. But then there's also challenges with VMs as well. Some of those challenges is that VMs are big. There are multiple gigabytes, and therefore very hard at times to move from your sandbox on your local machine to a public cloud or to a private cloud. At the same time, you have to always, set up and run the actual OS to even create a simple app, and that takes time, and that's impacts your overall productivity. And even the density within a VM is sometimes insufficient. You're underutilizing all those resources. So this came to this, these two kind of problem areas came to this new construct of containers, where within a container, you don't need to have a guest OS, you don't need to have a hypervisor, you just have those core parts of your application. You can spin it up really quick in a matter of seconds versus minutes. It's really small. It's only about in megabytes versus gigabytes. And you can also pack a bunch of these containers into a VM or onto a server. If you see Docker's website or their whole approach to things is they show all these containers on a ship, because you're able to fill up that ship and really utilize all the capacity that you have within your infrastructure. So I'm not going to talk super deep about this. This led to kind of the broader container revolution. This talks about this packaging technology that is most commonly known as Docker, but there's lots of other packaging technologies out there. And what's great about it is they're VM independent. So it's very easy to move these packages from one machine or one VM to another. They're also super lightweight and agile. They kind of work in this kind of microservices world that we were just talking about. And there's lots of images and ecosystem of tools and images for both development and operations that you can take advantage of. So the slide hits on some of the adoption trends, things that you guys were already saying. One is, Docker is the most popular, most well-known packaging technology, but there are a bunch of others as well available today. But the key thing is everyone's just doing this in dev test. Containers are really not being deployed in production today. And one of the primary reasons is it created a new problem. Devs were using it, but operations didn't know how to orchestrate or manage these container-based applications. And this has led to the creation of orchestration technologies like Docker Swarm or Kubernetes or Mesos DCOS. And Azure, we have taken advantage of those open source orchestration technologies, and we built a service on top to help you be able to orchestrate and manage your container-based applications. And we're unique in our service because we allow you to choose the orchestration engine that you prefer. So it's not a black box. You can say, I want to use Docker Swarm, I want to use Mesos DCOS. It's your choice. And it's really easy within a couple of clicks to be able to dive right into container management and deploy your containers in production. Now, I think I'm at the end of my time already. Is that correct? So we're not going to unfortunately do a demo. I do feel terrible about that. We ran over in time. So instead, what you should do next is we actually have dedicated sessions on all of these different application platforms in addition to that OS layer. We have a containers and the container service. I encourage you to go to those sessions. We also have sandboxes. And Jeremy showed you some of those for both app service and for functions. Another thing I want to highlight is we created a developer guide. There are so many decisions you make with building applications, and how do we make it easy for you to demystify when to use one service, one platform versus another? There's a guide to help you on that journey. And finally, if you want to get access to that economic report that I discussed that Forrester ran for us, there's a link there as well. We have lots more resources for developers that you should take advantage of. They're listed all here. I'll let you guys take quick pictures. It's the developer guide again, but then we also talk about a bunch of the training and certifications and forums that you can take advantage of with regards to developing solutions on Azure. And then finally, if we didn't answer all your questions, and if you haven't fully grasped what it takes to really understand what the Azure Application Platform is, I encourage you all to watch the debate tonight. And Clinton and Trump will duke it out to tell you which of the application platforms you should use to build your application. All right, thank you so much, and please fill out your evaluations.